Hello, this is John from caveofprogramming.com, and in this tutorial we're going to look at runtime exceptions in Java. So far we've looked at checked exceptions, and there are two kinds of exceptions in Java, two kind of basic kinds. And this is a question that people like to ask on interviews and exams quite a lot. What kinds of exceptions are there in Java? There are two basic kinds, and checked exceptions are the kind that you're forced to handle, and we've seen examples of those so far. Like if you call thread.sleep, for example, then this throws an exception, which is a checked exception, so you have to handle it. But there are also exceptions that you don't have to handle, that you're not forced to handle, and these are called unchecked exceptions or runtime exceptions. And an example would be division by zero. So let's say you've got a integer here, let's say int value equals 7, and let's say I say that value equals value divided by 0. This compiles, so I'm not forced to handle an exception here, but this does still throw an exception. So if I run this, it's going to give me some kind of, in this case, an arithmetic exception, divide by 0. And this is called a runtime exception. And in fact, if we look at arithmetic exception, let's go to a browser. Here it is. We find that it's a child class of runtime exception. And runtime exception, like all exceptions, is a child class of java.lang.exception. But the thing is that runtime exception and any of its child classes don't force you to handle them, which is why we don't have to put a try-catch in here. And the idea is that runtime exceptions are things that are really serious, basic, fundamental errors in your program. So if you've got a runtime exception, it's something that your program is unlikely to be able to recover from. And for that reason, it doesn't even force you to catch it. If your program is throwing runtime exceptions, then there's something really seriously wrong with it, which you should have addressed. Another good example would be a null pointer exception. Like I could say string text, and then without saying text equals new string or text equals some kind of text, I could try using a method of string like text.length, something like that. I could put in, let's say, sysal text.length. Now this probably isn't going to compile, just because it's going to tell me, if I say this, it's going to say that text may not have been initialized. But if I set text equal to null, now the compiler says, okay, you have initialized text with something, but I still can't call a method on it because all I've got here is a reference that points to nowhere. I haven't got an object containing actual code. I haven't got an object that contains actual implementation for this length method. So if I run this, I'll get a null pointer exception. And although null pointer exceptions are something that you tend to see a lot as a beginner, because you sort of kind of tend to lose track of the difference between a reference and having an actual object there. In a way, they're kind of one of my favourite errors, because you can usually fix them pretty quickly. Because if you see a null pointer exception, you've literally got some variable that's not referencing anything, and that's usually pretty simple to fix most of the time. And one more example that I want to show you before we look at something else in connection with this is the array out of bounds exception. Let's say you have an array of strings. Let's call this text equals new. Well, I could use the kind of shortcut for initializing an array and initialize this to 1, 2, 3. Now there are 3 strings in this array, and we start numbering the different values with index 0. So what would happen if I did sysout texts and I tried to access item number 3? So this is item 0, this is item 1, and this is item 2. And again, if I try to access text 3 and I run that, then I get this array index out of bounds exception, which again is a runtime exception. I'm not forced to handle it, but nevertheless it occurs. And again, this is just like the null pointer exception and the divide by 0, the arithmetic exception. This is pointing to a really fundamental problem in my program, which my program's not going to be able to recover from. Now, having said all that about not being forced to check these exceptions, you can still check runtime exceptions if you want to, but usually you don't want to, because usually what you're going to want to do, probably most of the time, is you're going to want to fix the underlying problem. But if you do want to catch a runtime exception, you can. So I could put a try in here, and I could enclose this in a try block, and I could say catch. And if I were to catch exception, then that will catch any exception that this code throws. So sometimes that could be useful, and I could do sysout e.get message, let's say, and maybe that will tell us something useful. So if I run this, actually the message isn't useful at all in that case, but yeah, I'm sure we could figure out something useful to do, like maybe, I don't know what toString looks like on, yeah, that's kind of more informative on array index out of bounds exception. So toString looks kind of more useful. Or of course I could do e.print stack trace, and if I wanted I can catch the specific exception. So to be more specific, I could catch all runtime exceptions by typing runtime exception here, and that's going to catch any runtime exception. Or I could catch the exact specific exception if I'm expecting it, like array index out of bounds exception, like this. So you can still catch runtime exceptions, but it's less common to do so, partly because you're not forced to, and partly because they do generally point to fundamental flaws in your program which you really need to fix. So that's it for this tutorial, and I think we've covered everything that's really important about exceptions for the moment. And there's still some quite fundamental things in Java that we still haven't covered in these tutorials. So my intention now is to carry on to fill in a few fundamental concepts, and later on probably I'll make some videos in which you can use to test your knowledge of Java. But we've still got a few basic things to cover, although we've certainly covered the majority of probably basic core Java by now. So that's it for this tutorial, and you can find this code, and I'll probably type out a little bit more of what I just wrote again on caveofprogramming.com. And until next time, happy coding.